Hey guys, so let's get crazy now with some of our derivatives. We've learned all the different rules. There's no more rules that we're going to actually go over, but we're going to start combining some of these rules. What if we're going to use the product rule and the quotient rule? What if we're going to use the chain rule and the quotient rule? That's what we're doing right now, okay? So let's look at this first problem here. Okay, we're going to start using a couple things at the same time. We've got a square root happening. If you remember, a square root is really just a 1/2 power. So I'm going to write that off to the side. We've got all of this inside a parenthesis to a 1/2 power. Well, if you see something to the 1/2 power, isn't that the chain rule? Well, all right, let's do the chain rule then on this. So we've got 4x cubed over 2 plus 3x squared. So when I take the derivative and I get dy, well, I'm going to bring the 1/2 down. That's part of the chain rule. 4x cubed over 2 plus 3x squared, okay, to the what power? -1/2. All right, but remember the next part of the chain rule is now we have to take the derivative of the inside. Well, the derivative of the inside is a fraction. It's dividing. How do you take the derivative when you're dividing? You have to use the quotient rule. So we're going to use the quotient rule now on the inside, okay? So if you remember, the quotient rule is the top times the derivative of the bottom minus the bottom times the derivative of the top all over the bottom squared. Oh, let's do it. So we've got 4x cubed times the derivative of the bottom. What's the derivative of the bottom? It'd be 6x minus the bottom times the derivative of the top, which would be 12x squared, all over the bottom squared. 2 plus 3x squared squared. Technically, you could leave your answer like this, technically, or we could simplify it a little bit more. If we simplify it just a little bit more, okay, I'm going to leave my 1/2 4x cubed over 2 plus 3x squared to the -1/2. On the next set of parentheses, I can combine these. That would give me 24x to the 4th. Okay, that's what I get when I combine those two together. If I distribute the 12x squared through, that would give me -24x squared minus 36x to the 4th. Can I combine -36x to the 4th and 24x to the 4th? Absolutely. That gives me -12x to the 4th minus 24x squared all over 2 plus 3x squared squared dx. What? Okay. It does help to go through and do these a little bit at a time. Now, I knew to start with the chain rule because that's the outmost side. Okay, as I'm looking at the whole picture, what does this generally look like? Well, it's something to the 1/2 power. That's how I knew to start with the chain rule. Then, once I took the derivative of the inside, is when I had to use the quotient rule. Okay, so I used the chain rule first, and the quotient rule. Now, there's times where we might use the quotient rule first, and then the chain rule. Let's look at an example like that. Here you go. This is a super similar problem. The only difference is instead of the whole thing being in a square root, only the bottom is in a square root. So as we're looking at this, generally speaking, okay, does it look like the whole thing is to a power or that there's a fraction going on? There's a fraction. So we're going to start off using the quotient rule. Then whenever we take the derivative of the bottom, we will use the chain rule. Okay, so let's do that. Now this bottom, remember, that's really to the 1/2 power instead of a square root. So when I take the derivative, dy, that's going to give me the top, 4x cubed, times the derivative of the bottom, which is 1/2 x squared plus 6 to the negative 1/2 times the derivative of the inside, 2x. Okay, because I just used the chain rule. I had to use the chain rule to take the derivative of the bottom. Minus the bottom, square root of x squared plus 6 times the derivative of the top is 12x squared all over the bottom squared. Well, if I square a square root, isn't that just no square root, no square? Yeah, so that just leaves me with x squared plus 6. Okay. Over here, that'd be a little bit tricky to combine, so they probably won't expect us to do that. However, could I combine the 2x, the 1/2, and 4x cubed? Yes. Don't forget your dx. So over here we get dy equals, let's see, 2 times 1/2 is nothing. Well, it's 1. Times 4, so that gives me 4x to the, I've got 1 and 3, so that gives me x to the 4th, times x squared plus 6 to the negative 1/2 minus square root of x squared plus 6 times 12x squared all over x squared plus 6. Whew, dx. Okay. That's roughly simplified as you're going to get it. Once you're in college, they might not want you to use the negative. So in that case, you'd have to do some really crazy math here to get that onto the bottom. Luckily, I don't care, so you can leave it just like that. All right, I want you to take a look at this problem here. What are we going to start off doing first? Are we going to start off doing a product rule between these two? Are we going to start off doing the derivative of cosine squared, which would also be kind of like a chain rule there? Well, which one would we do first? Think about it. Product rule or tangent cosine trig function rule? If you guessed product rule first, you are correct. We start off with the product rule, because as we look at this, it's really two separate functions, okay? You've got f of x and you have g of x, okay? There are two equations there. If you have two equations, you use the product rule, okay? So whenever we take the derivative of g of x is when we're going to have to do the chain rule and a trig rule right here. That's going to be a little bit trickier one. So dy, the derivative of y equals, let's see here, if you remember the product rule, it's the first times the derivative of the second. That gives you 2x squared times, what is the derivative of cosine squared x? Well, if you remember, this is really cosine x squared. Ooh, are we going to use the chain rule? We are going to use the chain rule. So bring the 2 down. It's going to leave you cosine x to the first power. Now we have to times that by the derivative of whatever was inside. What's the derivative of cosine? It is negative sine x. Okay. Then we add the second. So cosine squared x times the derivative of the first, which is 4x. Okay. Can I simplify this at all? Maybe a little bit. Okay. Don't forget your dx. So dy equals 4x squared times. All right. We've got cosine x. The negative from the sine x, I'm probably going to put in front of this 4. We've got sine x then. Now, like I said, the 1 I took off because if you just have an exponent of 1, that doesn't really matter at all. Plus, over here we've got 4x cosine squared x, okay? dx. Ta-da! All right, let's try this one now. What rule are we going to start with? The product rule, quotient rule, chain rule, the sign rule, your power rule, your quotient rule? Which one are we going to start with? Think about it. If you guessed the chain rule, you are correct. If you look, this is basically an entire function nested inside a square root. And the square root is basically to the power of 1/2. Again, if you said the chain rule, you are correct. So let's rewrite this so it looks a little bit more like a chain rule, okay? So sine squared x over 2x squared to the 1/2 power. Okay, so I've got something inside of parentheses to the 1/2 power. I'm going to use the chain rule. So dy equals, I have to bring the 1/2 down, so 1/2 sine squared x over 2x squared to the negative 1/2 power times the derivative of the inside, okay? The derivative of the inside, we're going to use the quotient rule, all right? Remember, the quotient rule is the top times the derivative of the bottom. So sine squared x times the derivative of the bottom is 4x. That was easy. Minus the bottom times the derivative of the top, which would be 2 sine x cosine x all over the bottom squared, which would give us 4x to the 4th, okay? Or I could just write it as 2x squared squared. 2x squared times 2x squared is 4x to the 4th. Anyway, if I wanted to go through and simplify this, make it look just a little bit nicer, I could. That would give me dy equals 1/2 sine squared x over 2x squared to the negative 1/2 power times, let's see here, 4x sine squared x minus, 2 times 2 is 4, 4x squared sine x cosine x all divided by 4x to the 4th dx. Whew. All right, here's a tricky one. I want you to give this one a try. Pause it if you need to. If you need some help, maybe think, well, what are you going to do first? You're going to do a cosine rule first. You're going to do a chain rule first. You're going to do a product rule first. All right, pause the video. Here comes the answer. All right, so as we're looking at this, we have basically two equations. We have the equation f of x. We have another equation, we'll call it g of x. They're being multiplied. If you have two equations and they're being multiplied, which rule are we going to use? We're going to use the product rule, okay? So dy is going to be the first 3x 4th plus 2 times the derivative of the second. The derivative of the second, we're going to use the chain rule on this, okay? So that's going to give me, I'm going to bring the 2 down, that's 2 cosine 2x times the derivative of the inside. Well, the inside was technically cosine 2x squared, okay? So we technically have a 1 on that. So now that I'm taking the derivative of the inside, what's the derivative of cosine? It is negative sine 2x. But now that we've taken the derivative of sine, well, from cosine to sine, we have to also multiply by the derivative of the inside, which is just 2. What? And we're only halfway done with the product rule. Now the second part is the second. So cosine squared 2x times the derivative of the first. The derivative of the first is 1/2 3x to the 4th plus 2 to the negative 1/2 times the derivative of the inside, which is 12x cubed. Now don't worry, on no test I'm ever going to give you questions this hard, but you should know how to do these type of problems because these are the types of problems that you might see in college, okay? All right, so we're going through, can we simplify anything? Let's look at the top row. Oh, don't forget your dx, meaning that it is a derivative. I've got 2 and 2. Yeah, so I can do dy is, can you see that all the way over there? Yeah, you can see that. Okay. 4 square root of 3x to the 4th plus 2 times cosine of 2x times, ooh, actually there's that negative. I'm going to put the negative in front of 4, just make it all look a little bit nicer. Sine 2x, 2, okay, plus, can I simplify this bottom at all? Ooh, 1/2 and 12x cubed. I can simplify that. That gives me 6x cubed times 3x to the 4th plus 2 to the negative 1/2 times cosine squared 2x dx. Now, I realize you could go through, you could simplify all this a little bit more. As far as calculus goes, though, you're never going to be tested to see how far you can simplify. Okay, your teacher might want it to look somewhat nice. If there's basic things you can simplify, like 2 times 2, they'll want you to go through and do that. They're not going to ask you to go through and combine sine 2x and cosine 2x. You can do it. They're not gonna have you do it. They're not going to have you simplify 6x cubed and 3x to the 4th plus 2 to the negative 1/2. They're not going to ask you to do that kind of thing, okay? They might ask you to make that a square root in the denominator. Maybe. That's about it, okay? So this would be your answer. If you wrote this down as the answer on a test, 95% of the time you're probably going to get the answer right. Or if the teacher isn't happy with your negative 1/2 exponent, they really wanted it as, let me write it how a teacher might want it. What would that be? Cosine squared 2x all over the square root of 3x to the 4th plus 2. If the teacher really wanted it like that and you wrote it the other way, they would still probably give you the majority of the credit. Okay? If the teacher didn't, then they're a jerk. All right? So, anyway, that would be your final answer. In the most simplified form, really leaving it with the negative 1/2 power is fine with me. All right, let's try this problem. This problem, you're probably scratching your head and you're thinking, tangent. I remember tangent, Harper Smith. If you remember and go back to the sine laws, the very first bit of the video had a table with a whole bunch of different rules on it that you could use. Well, one of those rules was how to take the derivative of a tangent. So let's look at this one. It looks like we have a function inside of a square root. Then we have something inside that's being divided. So are we going to use the quotient rule first, or are we going to use the chain rule first? We're going to use the chain rule first, okay? Because it's basically a function nested inside the square root. So when we go and do this, that gives me dy equals, remember this is really something to the 1/2. So I take the square root. Well, when I take the derivative, I bring the 1/2 down. Whatever was on the inside stays there, so cosine x over tangent x to the negative 1/2 power. Then we're going to multiply that by the derivative of the inside. The derivative of the inside is the top times the derivative of the bottom. So the top is cosine x times the derivative of tangent x is secant squared x. Okay, if you use that table, it would have told you. Also, on most tests, a teacher would give you like a cheat sheet with all these different formulas on it. Hey, that's nice of them to do that. Minus the bottom times the derivative of the top. The derivative of the top is negative sine. So if we get negative sine here, can I use that negative and turn this positive? Yeah. Divided by the bottom squared. Dx. Okay? And there's not really anything we can do to easily simplify this. There's not a lot of easy simplification. Could we maybe do something with these and combine them all and get something crazy somehow? Yeah, we probably could. Are we going to? No, we're not going to. Just leave it just like that. It's totally fine. Again, a teacher isn't looking for your ability to go through and simplify some of these advanced trig functions, okay? They just want to know, can you take the derivative? And remember, what does a derivative mean? It means this equation is the slope at any given point on this curve. So if we wanted to know the slope at pi, okay, at 1 radian, we would plug pi in for all the x's here. That would tell me the slope or the gradient at that point on the graph. That is what the derivative is telling us. What is the slope? What is the gradient at any point on this graph? Now, it's going to be really fun is here, but later on, when we move away from doing derivatives and we do what's called an antiderivative. So we figure if derivative is going from f of x and finding f prime of x, the antiderivative is we give you f prime of x and ask you, what was f of x? And there are so many cool implications that go on with doing an antiderivative. Sometimes we'll call it integrating, okay? So, want me to do one more problem? Yeah, let's do one more problem. Okay? All right, here we go. This problem uses every single rule that we have learned, okay? And we've got logs, we've got trig functions, we've got product rule, we have quotient rule, we have the chain rule, we've got chain rule. This has everything in it, okay? Even has a power rule. It's got everything. This is great. So the question is, though, what order do we do them in? Now remember, I like to break this up and think of it as chunks, okay? So over here we have a chunk. Over here we have another chunk. Inside of this chunk, there's more stuff. But basically right now, there's just 2 chunks. If there's 2 chunks and they're being multiplied, if there's 2 functions and they're being multiplied, that is the product rule. We're going to start with the product rule. So, see, can you see all the way over to right here? All right, so dy equals the first times the derivative of the second. So 2x cubed times the derivative of the second. The derivative of the second, now that I'm looking at this, I have parentheses, an exponent, and then something inside. Ooh, doesn't that sound like the chain rule? Okay, so if we're taking the derivative here, we're going to use the chain rule. That's going to give me 2 times whatever was inside, log base 5, 2x squared over tangent x, okay, to the first power. But now I have to, as part of the chain rule, take the derivative of the inside. If I'm just looking at the inside, is that product rule, quotient rule, trig rule, sine rule? What is it? Looks like it's going to be a quotient rule because you have 2 things being divided. I don't care what they are yet. I just know that there are 2 things being divided. Okay? As part of the quotient rule, it is the top, so log base 5 of 2x squared times the derivative of the bottom, which is secant squared x, okay, minus the bottom, which is tangent x, times the derivative of the top. The derivative of the top, if you remember with these log functions, is going to be 1 over ln, sorry, not ln, 2x squared ln of 5 times the derivative of the inside, because it's also part chain rule, okay? Whenever you see something in parentheses, you're using the chain rule. Derivative of the inside is 4x. Whew! That took forever. Okay, well now we've got the bottom squared. Tangent x squared, okay? So that was the first part of the product rule. If we stop here, we get it wrong, okay? Because remember, it's the first times the derivative of the second. This is a derivative of the second. But the second part of the product rule is you then have to add the second, which is log base 5 2x squared over tangent x squared times the derivative of the first, which is 6x squared. Okay, so this is basically one long formula. Oh my goodness. Can we simplify it at all? As I'm looking at it, I mean, we probably could have simplified the 2 and the 2 there to make it 4. Up here, there's not really anything you can do. Over here, there's not really anything you can do. Sometimes to make it look nicer, you would put the 4x in front of the tangent. You'd have the tangent trig functions at the end, so like the 4x and the tangent would switch places. You could potentially do something to get that down below. I wouldn't touch it. Here, same thing, you might move the 6x squared in front, but it's technically not wrong where it is. Honestly, the only thing you can really do is 2 times 2 is 4. That's the only way you can simplify this. So you just used all those rules. As long as you know the rules, it's not like there's all that much math involved. Whatever, Harper Smith, there's so much math involved. Well, yeah, you're kind of right. But this is the answer for that one. Okay, I realize that one was really long. That one used literally every single derivative rule that you have learned and that I'm going to bother teaching you in this class. Okay? There are a couple other derivative rules that you will learn later on when you're in college, but those are basically all of them. That is all of them. So, I hope that you enjoyed this. I'll probably do one more problem just for kicks and giggles. I realize I said that this is going to be the last one. If you think you've got it, you've got it. Okay? All right, this one looks really fun. It seems like a somewhat short equation. Harper Smith, that doesn't seem like a short equation at all. You're kind of right, it is a little bit longer. Just wait till we find the derivative though. Once we get the derivative, this is gonna seem like a small equation. So, remember with all of these, we need to look at it from a larger point of view. Don't think of all these little small numbers and stuff. We need to think, where are the functions, okay? So as I'm looking at this, I see a cosine cubed with all these things here. Well, if I get rid of that cubed there, doesn't that also mean the same thing as cubing all of this? If all of this is being cubed, I have the cubed of something. What rule do I start off with? If you guess the chain rule, you are correct, okay? So we've got dy equals, we're gonna do the chain rule, I'm gonna bring the 3 down. So 3 times whatever the inside was, cosine ln 2x squared times 3x all over 4x squared. Squared, okay? Because we had to subtract 1. Whenever you're using a power rule, you have to subtract 1. All right, next, as part of the chain rule, we now have to take the derivative inside. Well, if we're just looking at the inside, I've got cosine of something. Ooh. If I have cosine of something, what's the derivative of cosine? It is negative sine. Negative sine of ln 2x squared times 3x all over 4x squared, okay? Well, as part of taking the derivative of cosine, you still have to do the chain rule on whatever was inside of cosine. So the derivative inside here, what is the derivative of ln of 2? Well, if we look at it from a large point of view, okay, we don't look at all the tiny little numbers. Kind of squint. That's one way to do it. Just squint at it, and you can see, well, there's a fraction going on. Okay, so if there's a fraction going on, which rule are we going to use? Because there's obviously a fraction in there. We're going to use the quotient rule. The quotient rule is the top times the derivative of the bottom. So ln 2x squared times 3x times the derivative of the bottom is 8x. Okay? Minus the bottom, 4x squared, times the derivative of the top. The derivative of the top is something that's being multiplied. Ooh, if it's being multiplied, I have to use the product rule. Okay. All right, so product rule here. First times the derivative of the second. That is going to give me 3 ln of 2x squared times the second times the derivative of the first. The derivative of the first is going to be 1 over 2x squared times 4x. So if we're doing that times 3x, that's going to give me 12x squared, so plus 12x squared over 2x squared. Okay? All divided by, all of this gets divided by, because remember, we're still doing the quotient rule. We just finished up the product rule. Okay, that's the product rule. We still got to finish up the quotient rule, which gives me 4x squared squared, which is 16x to the fourth dx. Is this a small equation? Yeah, that's a small equation in comparison to this derivative that we just got. Can we simplify the derivative? We probably could. We probably could. Let's see. 3x and 8x, that gives you 24x squared. Over here, 12x squared divided by 2x squared, that's just going to be 6. Let's see here. Ooh, we've got x squared, and x to the fourth. So technically, we could take 2's off of all those. 2x is out. Let's see here, we've got 24, 4, and 16. All those are divisible by 4. Let's divide all three of those numbers by 4. That gives me 6, 1, and 4. Nothing else you can do there. Nothing you can do there. We could technically divide an x out here, which you technically could have done up here. That would have made the whole thing a lot easier. That's about it, though. That's as far simplified as you can get this derivative. Remember, what does this derivative tell you? It'll tell you the exact slope or gradient. Slope and gradient are the same thing. It'll tell you the exact gradient at any point on this curve. Okay.